All right, we're on the back side of day 7 notes. We're solving for an angle using trig. And so number 4 says Gwen has built and raised a wall of her new house. To keep the wall standing upright while she builds the next wall, she supports the wall with a brace, as shown in the diagram below. What is the value of P, the measure of the angle to the nearest degree, formed by the brace and the ground? Okay, so we already know what angle we're standing at and solving for. And so based on where we're reading from, 5.5 is the opposite side and 3 is the adjacent side. Okay, think about Sokotoa, some old horse, caught another horse, taking oats away. We labeled O and A, and so we'll be using the tangent trig function. So our formula is tangent theta equals O over A. And then we are going to go ahead and replace our 3 pieces. So we keep tangent, tangent. Theta is P, that's our angle. Opposite is 5.5. Adjacent is 3. Okay? Because we're solving for an angle, we use the inverse key. So we say P equals tangent inverse of 5.5 over 3. We grab our calculator. Second tangent will give you the inverse. And 5.5 divided by 3 is in parentheses. And when we hit enter, we end up with 61.3895. Dot, dot, dot. Rounding directions says nearest degree, just like on the front side of our notes today. And the 3 is not going to move the 1, so we're going to say that P equals 61 degrees. Okay. So I think solving for an angle is a little bit easier actually than solving for a side. Okay, but somewhat of the same process, except for that whole inverse part. All right, guys, no picture. So it says a ball is dropped from the top of a 45-foot building. So we got a building here. Yeah, someone's holding a ball up here. And it's going to drop. Okay, and so this is 45 feet tall, right? Once the ball was released, a strong gust of wind blew the ball away from the building. So my ball is not going to go straight down here. It's going to go and it landed 4 feet from the base of the building. So this distance here is 4 feet. Put a little right angle in there. Since that's the height of the building, height has to be perpendicular. Right? And they want to know to the nearest degree how many degrees the ball was blown off course. Okay? And so the distance away from the building is the angle that the ball was blown off course here. And so we're actually solving for this angle up here. If they wanted us to solve for the angle down here, they would have to say something about the angle the ball made with the ground. Okay. All right, so hopefully you guys can see your right triangle here. And we can use the little person at the top of the building. He's already standing at the angle, so we can use him as our stick person. And 4 would be the angle or the side that's opposite of our angle. And 45 is the adjacent side, since it's next to our angle. We don't have the hypotenuse, so we're not going to label it. Okay. According to Sokotoa, some old horse caught another horse, taking oats away. We have O and A again, just like in the last question. So we'll be using the tangent trig function. So tangent theta equals O over A. And then we'll replace our 3 pieces. Okay. So we have tangent of our angle, which is x. Opposite is 4. Adjacent is 45. Okay. Because we're solving for an angle, we say x equals tangent inverse of 4 over 45. We grab our calculator and we hit second tangent, 4 divided by 45, and we end up with 5.07960 dot, dot, dot. We go and grab the rounding directions, which again say nearest degree. Okay, and that's going to go ahead and stay 5 degrees. So it wasn't a huge gust of wind. It only blew the ball 5 degrees there off course instead of going straight down. Okay. All right, got one more question. And this one's about a roller coaster. Okay. It says a roller coaster travels 80 feet of track from the loading zone before reaching its peak. Okay, so when we get on a roller coaster, we get on at the ground, okay? And so this will be our loading zone. And it says it travels 80 feet of track from the loading zone before reaching its peak. So if it's reaching its peak, it's going up. And therefore, that is 80 feet of track. Okay, and so let's say that this is the peak. It says that the horizontal distance between the loading zone, which is here, okay, and the base of the peak, so straight down from the peak. Okay, so the horizontal distance, this is horizontal, going from left to right. And they're saying that that's 50, right? The horizontal distance between the loading zone and the base of the peak is 50 feet. Part A says model the situation using a right triangle. So I think that's a good picture. So part A is finished. Part B says find to the nearest degree again the angle at which the roller coaster is rising. So the roller coaster is rising here, and so we're going to call that our angle. All right. Based on solving and reading from that angle, 80 is my hypotenuse because it's across from the right angle, and 50 is my adjacent. A and H. So let's go ahead and say some old horse caught another horse, taking oats away. A and H make the cosine trig function. So write down the formula. Cosine theta equals A over H. And then we're going to go ahead and replace. And we end up with cosine. X is our angle. Our adjacent is 50. And our hypotenuse is 80. Okay? Because we're solving for an angle, we say X equals cosine inverse of 50 over 80. Grab our calculator, hit second cosine to get the inverse. Type in 50 divided by 80. Hit enter, and we end up with 51.3178 ... Rounding directions again said nearest degree. Okay, they won't always say that, but that was very common in our notes today. All right, and we end up with 51 degrees. And there we go. All right, so hopefully you now know how to solve for an angle. Okay, same procedure every single time. Just remember that when you're solving for an angle, don't cross multiply. Well, cross multiplying only helps you when you're solving for a side with trig. Okay, when you solve for an angle, make sure to use your inverse keys. Okay, all right, I'll see you guys on the next day of notes.